Hello everyone and welcome to Pentagon. Today's problem involves infinitely nested square roots. We need to find the difference of the square root of 2 times root 2 times root 2 and so on until infinity, and the square root of 2 plus the square root of 2 plus root 2 plus root 2 plus and so on until infinity. Please pause the video here if you'd like to try and solve this yourself. Now, there are several ways of how to solve this problem, but I'll be sharing what I think is the simplest way. We'll start by letting the values of these expressions be equal to x and y, respectively. And we need to find the difference between x and y. Very well, so let's solve for x and y. We'll start with x. We have that x is equal to the square root of 2 times the square root of 2 times the square root of 2 and on to infinity. Now, let's just square both sides of this equation. And we get that x squared is equal to 2 times the square root of 2 times the square root of 2 and so on to infinity. If you look closely here, you can see that this value is exactly the same as our x. Well, this is very convenient. We can now make a wonderful substitution. We can say that x squared is equal to 2x. And subtracting 2x from both sides, we get that x squared minus 2x equals 0. This is in the form of a quadratic equation where the leading term has an exponent of 2. From here we can factor out an x from the left-hand side and get that x times x minus 2 is equal to 0. Now from here we have two options. Either x equals 0 or x minus 2 is 0, which in that case x is equal to 2. One of these solutions is the correct one and the other is extraneous. Which one is the correct solution? That's right, it's x equals 2. Because in our initial expression, we are taking the square root of and multiplying an infinite number of positive values. And so, this expression can never equal 0. Thus, x equals 2. Right, now let's just solve for y. We have that y equals the square root of 2 plus the square root of 2 plus the square root of 2 plus and so on to infinity. Once again, let us square both sides. When we do this, we get that y squared is equal to 2 plus square root of 2 plus the square root of 2 plus, and on to infinity. Once again, we notice a pattern. If we look closely, we can see that this value is the exact same value as our y. And once again, we can make a very convenient substitution. We can say that y squared is equal to 2 plus y. And if we subtract 2 plus y from both sides, we get y squared minus y minus 2 equals 0. Here we have another quadratic, and this is conveniently very factorable. I'm assuming all of you know how to factor quadratics. If you don't, please leave a comment below, and I'll make another video explaining it. Back to our equation. We could factor this into two binomial expressions. And when we factor it, we get y plus 1 times y minus 2 equals 0. Once again, from here, we have two options. Either y plus 1 equals 0 and y equals negative 1, or y minus 2 equals 0, and so y equals 2. Again, we have one solution being extraneous and the other being the correct solution. So which solution is correct? That's right, it's y equals 2. Because in our original expression, we are taking the principal square root, or the positive square root. So an expression with this can never result in a negative number. Therefore, y equals 2. Wonderful. So now we have the values for x and y. All we need to do is take the difference. So we have x minus y, which equals, when we substitute in their values, 2 minus 2. And very nicely, the solution is 0. Thanks for watching this video. Please subscribe to our channel if you liked it. Thank you all, and I will see you in the next video.